we're on to straight fire number 9, which is using trigonometry to find sides. And in this question, if you pause the video and read it, after you've read it, you could realize that the information they're giving to you is basically all in the picture already, except for the x in the picture. We're looking for the height of the tower, so we want to place an x there. And then as a reminder, it says to round to the nearest tenth of a foot. So why is this question solved using trigonometry? Well, for the first reason, it's a right triangle. And the right triangle means that there's a possibility that SOH CAH TOA, the famous 3 proportions, could be used to solve the question. Another reason we know that it's trigonometry is because we're giving an angle and we're given one of the sides and we're looking for the other side. So it would not be the Pythagorean theorem. Pythagorean theorem is for right triangles when you know 2 sides and you want to find the third. So this one can be solved using right triangle trigonometry, or SOH CAH TOA. And probably by this time you may have already learned a way to memorize the order of those letters in these 3 formulas. And if you haven't, here's the most popular one probably of all time is Oscar had a headache over algebra. The one that I made up that I like quite a bit is soccer on hard concrete always hurts the old ankles. Or what I learned back in high school and middle school is just to remember the order SOH CAH TOA, just memorize the order. Alright, so which one is it for this picture? Well, we know it's a right triangle, and we know that this is called the hypotenuse. This is the biggest side of the triangle. It's always diagonally across from the right angle. The angle they're giving us, or the angle that we're interested in, if you visit the opposite side of that triangle, that is the opposite side. So being able to label the triangle correctly is very important. Now the leftover side at the bottom is the adjacent side. The word adjacent means attached, and it's attached to the right angle and the angle that we're interested in. So the adjacent side is the one that's attached to both angles. So now we've got the labeling down, right? We're looking for the formula that uses the opposite side and the adjacent side. Well, this uses the opposite and the hypotenuse. This uses the adjacent and the hypotenuse. It'd be the last one, TOA, that uses the O and the A. So the T stands for tangent. Sine, cosine, and tangent are always best friends with the angle. So right next to the letter N is going to be 78 degrees. And we're following the formula. It's opposite over adjacent. So in this picture it's opposite over adjacent, which is just x over 25. Alright, from there we can cross multiply, and what I like to show students is you can call 78, tangent of 78 over 1, and then just cross multiply to solve a proportion. So when you cross multiply, you get the answer just like that. X times 1 is x, and then 25 times the tangent of 78 will be what x is equal to. And then it's just a matter of typing it into the calculator and rounding to the nearest tenth of a foot. Okay, once it's typed in, it comes out to be 117.6157527. That's what the calculator screen tells me. Rounding to the nearest tenth of a foot. Well, the tenth place would be the 6. So it either stays a 6 or it changes to a 7. Since this number is lower than 5, it will stay as a 6. So the answer would be 117.6 feet. And the last thing I like to do is make sure that it looks right into the picture, and it does look look like it's properly sized, so that's a good answer. All right, and then we got one more question here on the bottom. This question, I want to make a small change to the directions. Why don't you read it first? Pause the video and then read it over, and then we'll talk about the small change. So now that you read the question, you can see maybe the part of it that seems the most strange is that they want the answer in simplest radical form. There is a way to do that, and I will discuss that later in the video. But for now, let's just change the directions to round to the nearest tenth, just like the one above. All right, let's begin figuring this out. So they want to know the perimeter of this triangle. And what do we know so far? Well, we know that the triangle on the left is a special kind of triangle. It's definitely a right triangle because CD is an altitude. And if you turn the triangle, if you rotate the triangle, maybe it also will look familiar as another special sort of triangle. It's an isosceles triangle. So if it's 8 here is one of the legs, it'll also be 8 there as well. And we're looking for the entire perimeter of the entire triangle, ABC. So I need to know how long each of the sides are. So let's start with this one. We want to find out how long this side is here. We could use this triangle on the white triangle here to figure out this length. Would it be trigonometry or something else? We'll put the X there. Well, you've got options. On this question, you could use trigonometry or you could use the Pythagorean theorem. What I'm going to do is use trigonometry to figure out the answer. So I would use 8 squared plus 8 squared equals x squared. A squared plus b squared equals 6c squared. You get 64 plus 64. We get 128. It's equal to x squared. So x would be equal to the square root of 128. Which, if you use the calculator to figure that out, just like I said, we're going to round the answer for the very first answer. Comes out to be about 11.3137085. I'm not going to round yet. I'm going to wait to the very end. The answer does look right in the picture. That looks like it could very well be 11 spaces for side AC. All right. We still have to figure out a few more sides of the triangle. That's one side down. Let's take a look at this side here. So would this be Pythagorean theorem or would it be SOH CAH TOA? Let's think about that for a second. That would definitely be not the Pythagorean theorem. To use the Pythagorean theorem, you have to know two sides. We have a side and we have an angle. But it is a right triangle, so we can use SOH CAH TOA. Sometimes I like to write down the abbreviation here to remind myself, especially when you're first starting out, that those are the three formulas that could be in play. Taking a look at the information we've got here, this is definitely the hypotenuse. And this side here is across from, or is on the opposite side of the angle. So this is involving the opposite and the hypotenuse. So the only one that would work out would be the sine. So we'll write the sine. The next to the letter n will go the angle, always. They're always best friends. Sine, cosine, and tangent are always right next to the angle. And if I follow the formula right, it's the opposite over the hypotenuse. And on this question, the variable ends up being on the bottom. You're still going to cross multiply, but this one actually could take two steps, the way that I like to show it. So cross multiplying these together gives you x times the sine of 30 equals 8 times 1, which is 8. When we cross multiply here, the answer is not there right away. We have one more step left to do. We've got to get rid of multiplying by the sine of 30. And to do that, you can divide both sides by the sine of 30. And then just type it into your calculator just like you see it. The sines of 30s disappear and you get x. And then 8 divided by the sine of 30, surprisingly, comes out to be 16. And it looks right in the picture at 16. Okay, we got to go all the way around the triangle, and so far we have gotten this side and this side, and we've gotten that this part's 8. The only part left to get is from D to B. So we're going to use the same triangle again, and we have some options. We could use the Pythagorean theorem to find the last side, or we could use SOH CAH TOA. This time I'm going to use the Pythagorean theorem. I think that's actually easier to do. In this question, I'll call this y, since we've used x a few times already. And looking at the picture, we've got a squared plus b squared equals c squared. So the 8 could be our a. That means that b would have to be the y. And the c we just found out was worth 16. So you get 64 plus y squared equals 256. So that brings us to y squared equals 192 when we subtract 64 away from both sides. Finishing it up by square rooting gives me that y is equal to the square root of 192. And then the calculator will take it the rest of the way. Since 192 is not a perfect square, it's 13.85 for y. So it's approximately equal to 13.8564. And then the last part is just to add those numbers together, which I won't have to do for you, but we'll just talk about it. So the answer would be this, plus this, plus this, plus this. That would be the entire perimeter. And then you just have to round it to the nearest tenth. Well, I might as well finish it. So bringing that all together tells me that the entire perimeter of the triangle is about 49.17 or 49.2 when we round it. Okay, going back to the original directions, it said to write your answer in simplest radical form. So let's talk about simplifying the radicals. So radical 128, I think most teachers would say, oh, you take that, and most students would think you take that and you break it up as a factor tree. So 2 and 64. And then you can take the 64 and write it as 2 times 32. And then take the 32 and break it up as 2 and 16, and take the 16 and break it into 2 and 8, and take the 8 and break it up into 2 and 4, and then take the 4 and break it up into 2 and 2, and that's all fine, but I actually think it's kind of a waste of time to go to do it in that kind of detail. But let's just do it that way. So radical 128 is the same thing as 2 times 2 times 2 times 2 times 2 times 2 times 2 with a square root on top of it. So it's, how many 2's is that? 1, 2, 3, 4, 5, 6, 7. So there's 7 2's. And the general rule is for every 2, 1 comes out, because 2 squared is 4, and the square root of 4 is 2. Another 2 will come out, another 2 will come out, and there'll be a 2 left behind. So 2, 4, 8 on the outside, 8 radical 2 is what radical 128 turns into. And if we've done this before in my class, you'll see that in my eyes, I'd rather just think of it this way first. And once I recognize that I see a perfect square, I can just slam on the brakes. So a quicker way to get the answer reduced to simplest radical form would just be to recognize if you've got a perfect square and just end it from there. So the square root of 128 is equal to square root of 2 times the square root of 64. So square root of 64 is just 8. So it's 8 radical 2. And isn't that faster? Let's see if I can use the same trick on the square root of 192. So simplifying the square root of 192, well, it's an even number, so I can definitely divide it by 2. So 192 split in half is 96. And I can split it again with dividing by 2, which brings me to 48. And I can do 2 and 24 with that. And I'm not really seeing any perfect squares in my factor tree, so I'm just going to keep on going. So 2 times 12, and then the 12 you can rip it apart into 2 times 6, and the 6 you can break into 2 times 3. So this one would end up looking like 2 times 2, 2, 2, 2, 2, altogether 6 2's, and a 3. For every 2, 1 comes out. So that would be identical to 8 radical 3 for the square root of 192. Okay, this is actually looking like quite a big mess here, but we've got a lot of thoughts down on this page. If you stuck with it the whole way through, the grand finale is right here. If you wanted the answer in simplest radical form, it definitely involves a lot more concentration to pull this off. But the perimeter would be 8 radical 2 plus 8 radical 3 plus 16 plus 8. And if you combine like terms, you'd get 24 plus 8 radical 2 plus 8 radical 3. I know there's another way to figure out these answers in terms of simplest radical form right off the bat, and don't really want to show you that shortcut because this is not that typical of a question to put it in simplest radical form. And the most important thing is that you can see the different ways to actually find the missing sides, and hopefully this reinforced what you know already, but also gave you a chance to take a look at some other things that normally we don't get a chance to talk too much about in class. All right, we'll keep on working really hard and make sure you get the SOH CAH TOA down. It could be really a fantastic thing to have under your belt ready to go when exam time comes around.